Ever wonder why diodes are so important in electronic circuits? Well, let's delve into that. Diodes, these tiny components, play a pivotal role in the world of electronics. They're the traffic cops of electronic circuits, controlling the direction of current flow. Much like a one-way street, diodes allow electricity to flow in a single direction, blocking it from going the other way. This function is of paramount importance in various applications. For instance, in power conversion, diodes are the unsung heroes that help convert alternating current, or AC, into direct current, or DC. They're also integral in signal modulation, shaping and altering signals to suit our needs. And let's not forget voltage regulation, where diodes maintain a constant voltage level, ensuring our devices run smoothly and efficiently. So without diodes, our electronic devices wouldn't function as smoothly as they do. Stay tuned to learn more about how these fascinating components work. Now that we understand their importance, what makes a diode do what it does? Let's break it down. A diode, at its simplest, is like a one-way street for electric current. It guides the current to flow in one direction, from the anode to the cathode, and prevents it from flowing in the opposite direction. Imagine you're a tiny electron, a part of an electric current. In a diode, you're on a journey from the anode, which is the starting point, to the cathode, which is your destination. You can't go back the way you came. That's the basic principle of how a diode operates. But what happens when you try to go in the opposite direction? Well, the diode has a way of dealing with that as well. This is where the concept of forward bias and reverse bias comes into play. Forward bias is when the diode's anode is connected to the positive side of a battery and the cathode is connected to the negative side. In this scenario, you, our tiny electron, can happily move from the anode to the cathode. The electric field of the diode supports your journey, and the current flows. On the flip side, reverse bias is when the diode's anode is connected to the negative side of a battery and the cathode to the positive side. Now you're trying to swim upstream against the electric field of the diode. It's like trying to walk up a steep hill. It's a struggle. And so, the diode blocks the current from flowing in this direction. This unique behavior of the diode has a vast range of applications in electronics, from rectification, converting alternating current to direct current, to voltage regulation, signal modulation, and much more. All in all, a diode is a crucial component in many electronic devices, controlling and guiding the flow of current with its one-way street policy. It's a simple yet powerful tool in the world of electronics. And that's how a diode controls the flow of current, quite like a traffic cop, wouldn't you say? So, what have we learned about diodes today? In a nutshell, diodes are the unsung heroes of our electronic devices. They play a crucial role in controlling the flow of current, ensuring it moves in the right direction. Think of them as the traffic policemen of the electronic world, guiding the current along the correct path. We delved into how a diode works, exploring the concepts of forward and reverse bias. In a forward bias, the diode allows current to flow freely, like a green light at an intersection. On the other hand, in a reverse bias, the diode blocks the current, acting like a red light. This unique ability makes diodes indispensable in various electronic applications, from power supply rectification to signal modulation. Remember, next time you use an electronic device, there's a diode working tirelessly to make sure the current flows just right. Stay curious and keep thinking beyond.